my name is Walter Unglaub, and this is how to see if a graph is linear. So here I have a graph, and I've labeled 3 different points A, B, and C, along the line, and I want to see if this is indeed a linear graph. To do that, I would actually have to calculate the slope between sets of consecutive points to ensure that the set of all points along this graph is indeed linear. And if those slopes are equal to each other, then indeed it is linear. So this slope for this segment would be m sub AB, and I'll call the slope between these 2 consecutive points m sub BC. So the idea is we want to test whether MAB is equal to MBC. So let's say that we have coordinates for the different points along this graph, because the graph, of course, had to be generated from a set of data points, or a function. In this case, we'll be using a set of data points where the coordinates for point A, for example, would be 1, 1. For point B, it would be equal to 2, 2. And for point C, we're going to have 3, 3. So you could probably guess that the slopes are going to be equal, but we're going to prove this. So MAB is equal to the change in x divided, the change in y divided the change in x. So in this case, the change in y is going to be this coordinate point minus this component of the coordinate. So we have 2 minus 1 divided the same thing, change in x, 2 minus 1. And this is simply equal to 1. We do the same for MBC, and we get the change in y over the change in x as 3 minus 2 divided 3 minus 2, which is also equal to 1. So, because all the slopes are equal, then this graph is proportional throughout the extent of the data set. Because of that, we can call this graph linear. My name is Walter Unglaub, and this is how to see if a graph is linear.